What's up everybody, this is Willy. Welcome back to Three Pedal Devils. In today's video, I'm going to update you on the progress we've made with Matt's engine situation on his Infiniti G35. We were all here working on it last night and we tried to film a vlog about it, but unfortunately I made some settings changes to our camera to try and improve low light performance and ended up turning off our stabilization, which absolutely destroyed our footage and made it horribly shaky and unusable. So I won't be posting any of that stuff, and instead I'll give you a quick walkthrough and update on what we've got going on. So let me grab this camera and get into that. So what have we done so far? Well, in the last two vlogs, you saw us pull the old blown engine out of the Infiniti. You saw that on camera. That engine is now currently, well, the heads and timing covers and oil pan are currently sitting right here, as well as the front end of the car. The old block is currently sitting on the floor there. And then off camera the other day, Max and Matt drove to Illinois somewhere to pick up a new used engine for this thing. So what they got is this bad boy under the plastic right here. I'm not going to unwrap it in this video because Matt already has it nicely wrapped up, but it's basically another VQ35 that has low mileage, used from a Japanese domestic market version of this car. We have the timing cover from that, valve covers, an oil pan, and some other accessories and engine mounts pulled off there. So let me just set this back down quick and tell you what the plan is for this thing. So basically, the old motor, the old engine, had a lot of wear, spun 2 rod bearings, all the main bearings were shot, and then all the rest of the rod bearings had extreme wear on them as well. That motor had like 220,000 miles on it, probably got starved of oil quite a few times just looking at the damage. Basically, that block is not ready to be put back together and thrown in the car. It's going to need some work. And the cheapest route for us and for Matt was to buy this used engine. The problem was his engine is the VQ35DE rev up model, which there's only one used one of those engines in the country, and it was like $5 grand. So obviously way out of a reasonable price range for Matt to get this thing back on the road. So Max did some digging and discovered that he could buy a VQ35DE non-rev up, swap the rev up heads onto the non-rev up block, and basically have a full working engine that will go back into this thing. So what we've done is pulled a bunch of stuff off this used engine. The heads currently are still on here, but we will be taking those off and swapping them with the heads from the old motor. Kind of confusing and a lot to follow. I probably didn't explain that super well, but let me just skip some of the details and show you exactly why the heads have to be changed. So the VQ35 rev up model has variable valve timing on both the intake and exhaust cam. I'm not sure which one's which, so I might have pointed at those wrong. But basically it's got cam phasing ability on both cams. But the VQ35DE non-rev up only has cam phasing on the intake cam. So that creates an issue, because now if we just threw this non-rev up engine back in Matt's car, his ECU, basically the car's computer, now is expecting there to be signal from the exhaust cam and then output, a signal to the actuator for the exhaust cam phasing system. And since that's not going to be plugged in because this engine doesn't have it, that thing's going to be going all haywire and it's basically not going to work. So the options were possibly to find an ECU to match the non-rev up engine and go through all of the absolute nightmare process of getting that paired and getting that to work right, finding a wiring harness, all that kind of junk. Or the other option is what we're doing, and that's to take these rev up heads, which have variable valve timing or cam phasing on both cams. You can see the ports here for both cams so that we have 2 sensors for the cam position. So we got intake and exhaust cam position sensors, whereas on that head, one of these, the exhaust port is blocked off and there's no sensor, and the cam doesn't have any grooves here for timing or for position sensing. So that's the main difference on this side of the cam. On this side, what we have on the rev up model is an exhaust cam phaser. This thing is mechanical. So on normal cam phasers, well, I guess I shouldn't say normal, but most of them, like this intake one, they're hydraulically driven. So it's phased based on an oil control valve that looks something like this, which is in a manifold with different flow ports, and basically you control this solenoid, which shifts a spool inside this body and opens up flow between different flow ports. You can see them better from this side. And what that does is it sends hydraulic or oil pressure to different chambers of the intake cam phaser, which then can phase the relative angle of that cam and either advance or retard timing for whatever purposes the engine needs. The difference with this exhaust one is it's not hydraulic. It's purely mechanical. So you can see it's got this torsion spring in the middle, the cam gear here, and then this little friction plate there. So these guys can actually move relative to each other. And what causes that to move is this little piece over here. Let me grab it. So this guy right here is actually what causes that exhaust phaser to phase. So what we've got here is it looks like some sort of solenoid, which has a coil wound inside of this piece right here, and it's got wires leading up to it. So when we energize that coil, it creates a force in this direction, which pushes this clutch plate against this friction plate. And what that does is that creates a frictional force between the two and causes this phaser, which I showed you before, to fight this torsional spring force and essentially phase this cam. This system can only phase in one direction because of how it's designed. I'm guessing it's can only advance exhaust timing, but I'd have to mock it up and think about that more to have a definitive answer. But that's how that exhaust phasing system works. Just to reiterate, so that the wiring harness with a connector that fits in this connector to control this solenoid is hooked up and the ECU will be reading everything right, as well as this extra cam position sensor that we have on each head. Those need to be retained to interface with the stock harness and ECU on this car. That's why we have to swap those old heads onto this new engine, take these heads off, not use them, bolt everything back up, and basically it should be good. But we also cannot use the new timing covers because this opening here for the cam gears is not the same. So you can see here we have just like a round bore. That's where that intake cam phaser would go. And if we go over here and look at the old timing covers, which Matt was cleaning up today, we see this big opening here. There's an extra, opening in this cover for that exhaust cam phaser to interface. So slightly different timing covers, slightly different heads, slightly different exhaust cam gears, but that's all very important so that this thing works in this car like it should. So that was probably all a little bit confusing, and I probably didn't explain it that well. But I think that should give you a good overview of what we're doing with this thing. And if you do have any further clarification questions on like what the hell we're doing with this whole Frankenstein build between this old motor, this new used motor, and all these different parts everywhere, just feel free to drop a comment below the video, and we'll either answer it right there in the comments or include it in our next vlog on this project, and be sure to clarify that for you. Another thing I wanted to mention, these oil control valves, I think those are pretty sweet because the company I work at designs these, and I'm actually building a prototype one of these tomorrow at work. So I think these things are pretty sweet, and I made a video tearing down a similar solenoid operated valve for an Acura transmission like a year and a half ago, and that's one of our most viewed videos, has like 10,000 views. People seem to enjoy it, so Matt should have an extra set of those after we get one of these engines working and back in there. If he gives me one of his extra ones, I think I'm going to tear one of those bad boys open and do a video explaining how it works, because I think they're pretty sick, and I haven't seen too many videos explaining that kind of stuff. So that being said, I hope that gives you a little update on our engine progress for Matt's car. We will have like a more, expected vlog next time we're here working in the shop, because we'll be swapping the heads over between the two. So that'll be kind of some substantial work that we'll be doing, and I'll be sure to vlog that if I'm here. That being said, this is going to be the end of this video update, because I got some work to do on my van. Hint, it involves designing and 3D printing and custom horn sounds. So I'm going to end it here, and we'll catch you in the next one. Thanks for watching. Be sure to subscribe, and that's it.
Psych!
We started an audio podcast called Cars and Cocktails. We had 2 episodes of that like a year ago. We just didn't really have a great podcasting setup, but we recorded 2 new episodes the other day and working on getting those posted on all different podcasting forums. So if you want to hear us get drunk and talk cars and roast each other, be sure to check into that. We'll probably have the link for it all over our YouTube and social media, so stay tuned. Thanks for watching. We'll catch you in the next one.